Okay, so we discussed N and how it relates to L. So now let's go out one. So let's go to N is equal to 2. So if, I'm going to use another example here. So now if N, so we're talking about an electron in the second shell, so it has N is equal to 2, because L equals N minus 1 down to 0 as its lower amount. Well, if 2 is equal to, N is equal to 2 minus 1, that starts at 1, and it goes at integer values, so the only other possibility is 0. And what this is telling us is that in the second shell, when N is equal to 2, we can have a p orbital, because L equal to 1 means p orbitals. L equal to 0 is an s orbital. It's just the alternate way to describe it. If L is equal to 1, we're talking about a p orbital. If L is equal to 0, we're talking about an s orbital, and so on. So other options, if we go out to N is equal to 3, the third shell, well, we can add one more type of orbital, so L is equal to N minus 1, so that's equal to 3 minus 1 equals 2. But it can also take on the value of 1 down to 0. 2, 1, or 0, and so there's s orbitals in the third shell, there are p orbitals in the third shell, and this new one, 2, L is equal to 2, is what it means to have a d orbital. Okay, so that's the type of orbital, and that's described by L. The next quantum number is m sub L, subscript L. And this tells us how many of each type. And these can take on the value that are dictated by whatever the value of L is. So we're going to start with L as the highest value of m sub L, and it can change in integral values down to minus L. So let's take an example we just did for a d orbital. So for a d orbital, that means it has quantum number of L equal to 2. And if we have our L value of 2, we're going to start up here for m sub L, and the possibilities are that it can be L, so it can be 2, or it can be minus L, that's a minus 2, and then it's going to change in inner values. So m sub L can be change one value to 1, change another value down to 0, change another value down to minus 1, and that leaves us now for the next step of 2. And this is going to tell us, okay, there are 5 of these, and so there are 5 d orbitals, d1, d2, d3, d4, and d5. The electrons take on whatever the set of quantum numbers are that are appropriate. So if I've got a 4d electron, the n is equal to 1, L is equal to, well, S equals 0, P equals 1, D equals 2, so L is equal to 2. And then we don't know which of the 5 possible d orbitals are chosen. It's one of the 5. So it could be, we write that as n equal to 4, L equal to 2, and m sub L is equal to either 2, 1, 0, minus 1, or minus 2. Now the last thing is the m sub s. This is the electron, and the electron can either have a spin of 1/2 or a spin of minus 1/2. And we don't know which one it is, but it can be one of the two. So if we have this electron that's in the 4D, it can either have spin 1/2 or spin minus 1/2. It can't be 1, can't be 4, can't be 7. It is either 1/2 or minus 1/2. And that is the overview of the quantum numbers, and I hope that helps you understand what can be a fairly confusing topic.